Space is vast. It's filled with wonders, nebulae painted across the cosmos, distant galaxies twinkling like celestial fireflies, and black holes warping the fabric of space-time itself. But space also holds dangers, invisible forces that constantly bombard our planet. These are cosmic rays, subatomic particles traveling at nearly the speed of light, carrying immense energy from the most powerful events in the universe. While we gaze at the stars, marveling at their beauty, we seldom consider these unseen visitors, these cosmic bullets that relentlessly pierce our atmosphere and impact our world in ways we're only beginning to understand. So, what exactly are cosmic rays? Imagine the tiniest particles imaginable: protons, electrons, and atomic nuclei, stripped bare and accelerated to unimaginable speeds. These particles are not from our solar system. They are cosmic travelers, originating from the most violent events in the universe: exploding stars, active galactic nuclei, and perhaps even the enigmatic collisions of black holes. These cosmic accelerators act like giant slingshots, flinging particles across vast distances, some eventually finding their way to Earth. As cosmic rays journey through space, they carry with them the energy of their fiery births. They travel at nearly the speed of light, making the journey to Earth from even distant galaxies in a cosmic blink of an eye. During their travels, they encounter magnetic fields, galactic highways that can alter their paths, scattering them across the cosmos. This makes tracing their exact origins a challenge, a cosmic puzzle that scientists are still piecing together. While Earth's atmosphere and magnetic field provide a natural shield against most cosmic rays, some of these high-energy particles still manage to reach our planet's surface. While the dose from these cosmic rays is relatively low, their high energy can cause disruptions in electronics. When a cosmic ray particle collides with an atom in the atmosphere, it triggers a cascade of secondary particles, like a miniature cosmic firework. These secondary particles can then interact with electronics, causing what's known as a single event upset, or SEU. Imagine a computer chip, its intricate circuitry carrying out billions of calculations per second. An SEU caused by a cosmic ray can flip a single bit of information from a 0 to a 1 or vice versa. In most cases, such an error is inconsequential, corrected by the system's error-checking mechanisms. However, in critical systems such as those used in aviation, healthcare, or power grids, even a single bit flip can have significant consequences. Protecting our technology from cosmic rays is a multifaceted challenge. It requires a combination of material science, engineering ingenuity, and a deep understanding of the behavior of these high-energy particles. One approach is to use radiation-hardened electronics, designed to withstand the impact of cosmic rays. This involves using specialized materials and manufacturing processes to create chips that are less susceptible to SEUs. Another strategy is to employ redundancy in critical systems. By having multiple copies of essential components, engineers can ensure that if one system is affected by a cosmic ray, another can seamlessly take over, preventing any disruption in operation. This is particularly crucial in aviation, where a single error in flight control systems could have catastrophic consequences. Spacecraft in particular require robust shielding against cosmic rays. Orbiting outside the protective layers of Earth's atmosphere, they are constantly bombarded by these high-energy particles. Engineers use a combination of materials, such as aluminum, polyethylene, and even water, to create shielding layers that absorb and deflect cosmic rays, protecting sensitive equipment and, of course, the astronauts on board. As we venture further into space, the challenge of protecting our technology from cosmic rays will only become more significant. Long-duration missions to Mars and beyond will expose astronauts and equipment to higher doses of radiation, increasing the risk of both short-term and long-term health effects. Researchers are actively developing new materials and shielding strategies to mitigate these risks, paving the way for safer and more sustainable space exploration. But cosmic rays are not just a threat, they are also a valuable tool for scientific discovery. By studying their composition, energy spectra, and arrival directions, scientists can learn about the most energetic events in the universe, from supernova explosions to the activity of supermassive black holes. These cosmic messengers provide us with a unique window into the workings of the cosmos, revealing secrets about the origins of the universe and the nature of matter itself. The study of cosmic rays is a journey into the unknown. Every particle that reaches our detectors carries with it a story, a tale of cosmic acceleration, interstellar travel, and the violent beauty of the universe. As we continue to unravel the mysteries of these high-energy particles, we deepen our understanding of the cosmos and our place within it. The story of cosmic rays is still being written, a cosmic narrative that unfolds with each new discovery, reminding us of the vastness of the universe and the boundless possibilities of scientific exploration.